Hi, we are from Group 3. So today we are going to present about Lab 9, rolling disc on an inclined plane. For the theory part, we will include two types of theory. The first one will be free falling, and the second one will be the moment of inertia. For free falling, describe that an object that free fall only affected by gravity. It does not affected by weight, size, and shape of the object, and the acceleration for free falling body is always equal to gravitational acceleration 9.81 meter per second square. The final speed also will be square root 2 times gravitational acceleration and time with height where it's released. Galileo also conducted an experiment that relate displacement and time, and he found that the displacement is depend on square of time. For moment of inertia, it describes the resistance for an object to change rotational speed. So let's say we want to maintain an angular acceleration value. So the larger moment of inertia of an object require larger torque compared to smaller one. For rolling motion on an inclined plane, it will be the combination between translation and rotational, and it include the theory, the free falling theory and moment of inertia. The acceleration equation will be like below. For the experiment setup, these are the things that we will be use. The first one is large disc, small disc, protractor, book, stopwatch, drawing board, and vernier caliper.
Good day everyone, my name is Tan Kai Wen, ID BMM2521, and today I'll be presenting the experimental procedures for Lab 9. For the experimental procedures, we start off by adjusting the plane to the desired inclination as shown in the first figure. Next, we place the cylinder on the track starting point, and we have to ensure that the rotating axis midpoint is located exactly at the starting point as shown in the second figure. After placing the cylinder on the starting point, we release the cylinder and immediately start the stopwatch as shown in the first figure. After that, once the cylinder has rolled down to the floor, we immediately stop the stopwatch as shown in the second figure. Next, repeat step 2 to step 4 two more times to reduce the errors of the experiment, and we calculate a mean value of time taken and record the findings as shown in the figure below, where T1, T2 and T3 are the time taken for the cylinder to roll down and Tmin is their mean value. After that, repeat step 1 to step 4 with different inclination. After completing all the inclination angle, the experiment is repeated with a cylinder of different diameter. The second figure shows the cylinders with different diameter used in this experiment. Now let's have a look of the rolling motion video of both cylinders. That is all from me. Thank you very much.
I will present the result for the red line. So this is the formula I'm going to use for acceleration, inertia, and time, calculator time. And this is the parameter, inclined angle, inner radius, outer radius, and the distance. So this is the data I get for the this to reach 0.59 meter distance. So which has large disk and the small disk. For example, the sample calculation, uh, T mean equal to T1 plus T2 and T3 and divided with 3. And I got 2.1 second. So this is the data measure and calculated for the large disk and the small disk. For example, I calculate with uh, for the large disk, I calculate with the outer radius and inner radius with its mass. So the formula is mass moment of inertia. I just put all the information here into the formula and got the value we want. So also same as acceleration, using the information we get, we put it the inertia in the formula. So we get 0.2416 meter per second square. And for calculate time, also using formula with the S, which is 0.59 meter. And finally, we get the value for calculate time, 2.21 second, and the deviation, T measure minus T calculated per T calculated, and get the deviation, 4.977T%. Okay, that's cool.
Hi, my name is Ahmad Nakiuddin Alimi bin Rosli, and my metric number is MA20128. And I am going to present you about the discussion. So the first question is how to adjust the angle of inclination. So in our experiment, we use books to adjust the angle of inclination. This is the most practical way and cheap way for our group to conduct this experiment. So the second one is, what is the purpose of angulometer? So angulometer is a tool that is used to measure the angle of inclination with precision. So we're going to another slide. And third question is, can you give the alternative method to measure the angle of inclination? So the alternative way to measure the angle of inclination is by using the protractor. Fourth is how to make precise alignment for these experiments. So to avoid error, um, we need to conduct the experiment on a flat surface, and we need to double check the angle to make sure the accuracy. Fifth is why the angle higher than 7 degree cannot be used for this experiment. So when the angle is higher, the disc will have a higher potential energy, so resulting in a shorter time taken and higher rolling speed. So it can potentially affect the data and result. So second last question is, give the definition of free fall theory, which discovered by Galileo. So object with different masses take equal time to fall from the same height if there is no air resistance. This is because all objects fall towards the earth is the same acceleration regardless of their mass, which is 9.81 meter per second. So the last question is, give the factor that cause free falling body. The answer is vacuum and gravity.
Hi, my name is Danish Hakimi bin Raismadi. My metric number is MA20148. I will continue for discussion. What is relation between angle of inclination and the rolling disc? The angle of inclination determine the disc acceleration according to the acceleration formula. The disc acceleration will also increase when the angle of inclination increase. Next, what is term of inertia? Inertia is tendency of matter to remain unchanged and continue in its rest state or uniform motion unless an external force is applied to change the state. Why repeatability measurement is important? The repeatability of measurement is crucial as variation in measurement can affect how the results are interpreted. By measuring the average data, measurement error can reduce and accurate result can be obtained. This is free body diagram. Next is why deviation occur between the calculated and measured value. The properties of the material themselves, such as friction, cause deviation between calculated and measured value. Human error can cause this to happen, such as when an extra external force is applied when the object is released to roll. Last, improvement of the experiment. To prevent any higher deviation when measuring the data result, it is important to set up the experiment apparatus properly. To ensure smooth rotation, the inclined plane need to be balanced with the ground. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Nabila binti Zaini. My ID number MA20144. Okay, in this video, I will explain about conclusion and appendix. So, the conclusion in this experiment, we are able to conclude this experiment with the goal having been met. So, through ruling experiment, we can study the mass moment of inertia. The law of falling bodies on an inclined plane can be found and the mass moment of inertia can be studied using a pendulum experiment. Depending on the use, the moment of inertia has a different value. Rolling this on an inclined plane accelerates differently depending on its mass and diameter. So next, I will explain about appendix for the experiments that have two discs, which is large and small disc. So the mean time for large and small disc is different. As you can see from the slide given, okay, the value is different. So next, I will explain about size of cylinders. Okay, that have three types of size, which is outer diameter, inner diameter, and thickness. The size of cylinder must be in millimeter. That's all from me. Thank you.